everyone, I am Sneha, co-founder and CEO DevCompass, and I'm back again. I hope you are happy to see me as much as I am happy to see you guys, and I hope everyone has done all the walkthroughs, went over all the videos, did your assignments, attempted that quiz in between the walkthroughs, and you're all ready for stage 3. This is going to be a really fun section, and I personally loved making and shooting all of these videos for this particular section. So let's get started. Okay, so we're going to talk a lot about multi-agent systems. At the end of stage 2, you had a customer agent that works reliably and you were so proud, right? One Claude instance, a handful of tools, a very clean loop for a lot of use cases. That's exactly the right architecture, and you should stop there. But some problems are too big, too parallel, or too complex for a single agent to handle well. And this video is about recognizing when you have hit that ceiling and what the multi-agent architecture looks like when you cross it. So let's get started. Okay, so 3 decision criteria on screen. When do you not need multi-agent systems? Because if we are good with a single agent, why do the extra effort, right? So these are the 3 situations where a single agent genuinely struggles and multi-agent architecture earns its complexity cost. I want you to understand all 3 because the exam will present scenarios and ask you to justify an architecture choice. First, independent parallel work streams. Let's look at an example. A research task that requires simultaneously searching 5 different data sources. A single agent has to do it sequentially. It searches one, waits for the result, adds it to the context, searches source 2, waits, and so on. Repeat. That takes time and burns context with immediate results. 5 sub-agents can search all 5 sources simultaneously, each in their own isolated context, and return results to a coordinator at the same time. The wall clock time for the task drops dramatically if your problem naturally breaks into independent parallel tracks. A single agent is a leaving performance in the table, literally. Second, different tool configurations required. Remember the scoped access principle from stage 2, where different agents should have access to only the tools they need. If you don't, please go watch the last video from stage 2. Sometimes the work itself requires fundamentally different tool sets. A research sub-agent needs search and retrieval tools. A writing sub-agent needs document creation tools. A verification sub-agent needs fact-checking tools. You could give one agent all of those tools, but you have now created an agent with an enormous tool list, which is increased the chance of misrouting and eliminated the entire blast radius protection that we discussed in stage 2. Separate agents with separate tool sets is the cleaner, safer design. So, you know what to do. Third, context window reliability. Look at this one very carefully, and I think I've been emphasizing a lot on context windows since the start. So a single agent running a very long complex task which needs 40 turns of conversation, large tool results, multiple document injections will start to degrade. We covered this in stage 1 video 3. So if you have not watched it, please go watch. The lost in the middle problem. For tasks where the total work exceeds what a single context window can hold reliably, breaking the task across multiple agents, each with a very fresh, focused context, produces more reliable results than asking one agent to hold everything. So these are the 3 scenarios where multi-agent architecture comes in. Before we look at how multi-agent systems are structured, I want to show you what the transition looks like from the single agent architecture you already know. So left side is a single agent. This is the system we have already built. One Claude instance, tool connected via MCP, hooks enforcing business rules, a customer talking to it directly. You know everything on this side of diagram. I really hope you do. Right side is the beginning of what stage 3 will actually build. The same customer, but now instead of talking directly to Claude, the customer request goes to a coordinator. A Claude instance whose job is not to answer the customer directly, but to break down the request, delegate work to sub-agents and synthesize the results back into a coherent response. Below the coordinator are 2 sub-agents. Each sub-agent is its own Claude instance with its own context, its own tool set and its own focus job. The account lookup sub-agent handles get customer. The order lookup sub-agent handles lookup order. So each does one thing. The coordinator knows what each sub-agent does and orchestrates between them. This is the architecture that we're going to build in stage 3 capstone project. Everything in the next 5 videos explains how to make this work reliably, because it introduces problems that doesn't really exist in single agent system, very different contexts. So communication between agents, failure in one sub-agent affecting the coordinator. So we're going to work through every one of those problems. Now I want you to show you what multi-agent architecture actually enables concretely with the research scenario from the stage 3 capstone. So let's look at the timeline diagram on screen. So top row is single agent sequential. The agent receives a complex customer query that requires looking up account information and 2 separate order records. It calls get customer, waits, gets the result, appends it to the context, then calls lookup order for the first order. Again waits, gets the result, appends, and so on. So total time is 3 sequential tool calls, one after another. Each wait is a real latency. API calls, database queries, and each result is sitting in the same context window the whole time. Whereas bottom row is multi-agent parallel. The coordinator receives the same query. It spawns 2 sub-agents simultaneously. Sub-agent 1 looks up the account. Sub-agent 2 looks up both orders. Both are running at the same time. So the coordinator waits for both to complete and then it synthesizes the results into a response. So total time, roughly the time of the single longest sub-agent task, not the sum of all tasks. So the 2 things to notice first is the wall clock time is shorter. The bar on the timeline is narrower for multi-agent. Second, each sub-agent's context contain only its own work, not the accumulation of everything. The account sub-agent context has the system prompt and the account lookup. The order sub-agent's context has the system prompt and the order lookups. Neither one is carrying the other's work, and that is what we mean by context isolation, and that is going to be the subject of the next video. But before we end up, we need to figure out the decision framework. Not every problem needs multiple agents, like I mentioned at the start of the video. In fact, defaulting to multi-agent when you don't need it makes your system harder to debug, harder to maintain, and introduces failure modes that simply don't exist in single agent systems. Look at the decision card on the screen. Can this task be broken into independent work streams that would benefit from running in parallel? If no, stay single agent. Parallelism is the primary reason to go multi-agent. If the work is sequential by nature, step B requires the output of step A. Splitting it across agent doesn't help and adds coordination overhead. So you will stay single agent. If yes, next question. Do different parts of the task genuinely require different tool sets or configurations? If no, a single agent with all the tools might still be fine. If yes, multi-agent starts to make more sense. And the third check. Does the total work risk exceeding the reliable capacity of a single context window? If the task is super short and focused, one context window is fine. if it is long, complex, and involves large amounts of retrieved data, multiple focused contexts are more reliable so that it does not get lost in long conversations. So if all three yes answers, a super strong case for multi-agent. If one or two yes answers, evaluate the trade-offs. And if it is an all no, please stay single agent. Don't add complexity to what you really don't need. So that's it for this video. We talked about multi-agent, parallel work stream, different tool sets, and a lot of context reliability. Parallelism is the primary benefit. Sub-agents run simultaneously, reducing the wall clock time. If you default to single agent, only go multi-agent when the criteria are clearly met. That's it. In the next video, we're going into the most common failure mode in multi-agent systems, the one that almost every developer hits on their first build. It's called context isolation, and it's about what happens when you assume sub-agents can see things that they actually can't. So weird, right? But I will see you in the next video. Please head over to your assignments and walkthroughs. Thank you.